Hello everyone, welcome back to my computer project. I've started working on some of the RAM stuff. So this board here isn't actually the memory, it's for addressing the memory. So we'll see here there's 8 inputs, actually there's 9 inputs. So 8 of them are actually the address you want to access from memory. And the last one is just like an enable pin, so you can just not bother with with memory at that specific point. So I've only got the first 4 bits connected at the moment because that's all I'll need to start off with. And these feed into a bunch of inverters here. And then there's 4 inputs. These are swapped into like the input and the not input. And then there's all these diodes. These are actually AND gates, but they're open collector AND gates. So they'll be sinking current unless they're blocked. So when all the connections, when all the lines for these 4 diodes are high, for example, it will basically be true. But what that means is it's no longer sinking current, it's blocked, it's impeded. But everything else will sink current. And then these feed out to these 16 pins. So the way the RAM will work on top of it is that when you want to write to a specific bit, it has to be high, it has to be impeded so that the switch can happen. I'll probably do another video on that, going through the simulations I have, like the plans and stuff. But yeah, that's basically what this does. 4 inputs, 16 outputs. It's basically a 4 to 16 demultiplexer. And this 16 lines is enough for the 16 bytes I want to start off with. But there's enough room here for another one of these, another 4 to 16 demultiplexer. And that will go from here, and it'll be over there, and it'll go out to these 16 pins. And so that's only 32 pins, but this will be able to access 255 bytes of memory maximum. And it does that by these 16, which choose which byte to access. They will always be going out to every board, but these ones will act as enable pins for each RAM, each board of RAM, each with 16 bytes on it. So you'll be able to say, I want this part of this byte and this RAM memory board, but I want it from X memory board out of 16 boards. So that's what that's doing, and this is basically done for what I need it for. I'm gonna jazz it up a little bit because you see I've got power and ground here, but I'm also gonna have power and ground here and on the back sides as well. Just so it's, I can have, it's going to be doing a fair bit, so I want it to have as much access to ground and power as possible without causing, having too much resistance on a single line, so you can choose multiple ways and stuff. Because that has been a problem on the entire computer build. You can measure like a fraction of resistance between just like the power line over here, like the VCC over here and VCC over here. There's quite a bit of resistance, only like 0.3 ohms or something like that. But that does actually cause voltage problems all over the place. So just doubling up on that as much as possible is what I'm going to be trying to do. Anyway, I've got it set up here for a quick test. So I have a little switch here, a little dip switch here, that will allow me to set these bits. And each of these, so these are all high, and then they'll sync through there when they're not active, basically. So the one that's off is the one that's selected, as you'll see here. It'll be a bit too bright. Hold it like this. It might be easier for me to hit the switch as well. So at the moment you can see this is 0, 0, 0, 0, 0. They're all off, and this one's off. But if I change it, oh great, no, I'm pushing it the wrong way. That doesn't help. Yeah, you'll see it goes to the next one. If I take that back and put on the second one, you'll see it goes to that one, and then the third one, or the fourth one technically, and there. And yeah, so this works for all of them. If I put them all high, it'll go to the last one. -1 from there, it'll go to second to last one. -3 from there, it'll go to like that one. No, that's not right. There, that one. So yeah, so these switches are really tiny, and I've got no nails. So yeah, that's what that's for, and this will allow me to access. So the one that's off, yeah, this one would be the byte that is going to try and drag from memory, and that's going to be a whole different kind of beans. This is just for selecting it. So there'll be the RAM board itself, and then there'll need to be a board for reading and writing. And that's a little tricky, but I'll probably try and do the simulation video next, just so you can get an idea of the boards I'm going to be making. But yeah, that's that, and it's all nice and working. Thank you for watching, and I'll see you next time.